So what do you presume that we're going to have to do with this one? Again? No. No. Before you do that, we will eventually, right? But what's the problem here? They're different functions, right? How are we going to make them all the same function? Alexis? Yeah, change the secant squared to 1 plus tan squared, right? We got to make this all the same trig function before we can go any further. So let's write this as 1 plus tan squared minus 2 tan x equals 4. And now we'll combine like terms, get everything on one side, 0 on the other. Tan squared minus 2 tan squared, tan. And now the 1 subtract 4 will be minus 3. Okay, that looks like a pretty simple quadratic, right? That's what two numbers, the product is negative 3 and the sum is negative 2. Cameron? Negative 3, positive 1, right? So this will be tan x minus 3 times tan x plus 1 equals 0. Right, and then we'll set each equal to 0. Tan x minus 3 equals 0. Tan x plus 1 equals 0. Solve. Tan x equals 3. Tan x equals negative 1. I think we just saw this one, right? This second thing. Where does tangent equal negative 1? 3 pi over 4, 7 pi over 4, keep adding pi every time you get to another place. So that part's easier. We can just say x equals 3 pi over 4 plus n pi. This one, you know, in terms of unit circle values, we don't have one. Right? I mean, we would have a square root of 3, but we don't have any of the combinations of these things where you would divide sine by cosine and get 3. So you just have to do sine inverse. Do x equals tan inverse of 3. I don't have my calculator going there. Oh, I'll just use it from the book. That one was arctan of 3. And what mode do you think you'd want to be in? Radians. I mean, everything's set in radians, so we'd stick to radians. Mode is radians, second quit. Tan inverse trace. 1.249. Okay, and then again, we have to find, that's not just one value, right? That 1.249 gave us one value, which is actually in the first quadrant, but it's going to repeat itself every pi around the circle. So we still have to say plus n pi. So you might get to a point where you need to use the inverse function, that it's not just something you could look up on the unit circle. Okay.